Continuing our discussion further, in direct addressing mode, we have effective address, which is the address at which an operand can be found in the memory location. So here we require a single memory reference in order to access the data or operand. However, to calculate the effective address, we do not need any formula because directly it represents the address of the operand. But the address space that is available is limited in nature. Coming to indirect addressing mode, here to find the effective address, we need to make multiple references to the memory. For example, if we have an opcode and address A, so this address A will in turn contain another address which points to the operand in the memory. So here, multiple memory references are required in order to find the operand. Hence, this process is a slower one, and the address at which an operand is found is known as effective address. So in this example, pointer to operand is an effective address. If this is represented as B, then the location B can be taken as an effective address. For each reference and for each access to memory, we are representing parentheses. Coming to the next addressing mode, we have register addressing mode, where here the operand is present in the register of a computer. Hence, the effective address represents the address of the register where an operand is located. So there are limited number of registers here and the address field required will be very small in nature. Shorter instructions can be supported and it supports faster instruction fetch. When we wanted to represent the same, we have an opcode and in the instruction, the address part of the register will be specified. And now we do not need any kind of memory reference because our instruction directly resides inside the register. So this register will contain your operand. In some cases, your operand will not directly be available in the register, but in fact, the address of a memory location will be loaded into the register. So in that case, we refer to that addressing mode as register indirect addressing mode. So operand is in the memory cell pointed to by the contents of the register. Hence here, as we need multiple references to register as well as memory, the address space need to be large enough. Only fewer memory accesses are required when compared to the indirect memory addressing mode. Here, the instruction will contain opcode and the address of the register, which in turn contain the address of your operand pointing to a memory location. So, multiple references are required to fetch a particular operand from the memory. Next, we have is displacement addressing mode. In displacement addressing mode, the address field it holds two values. The first value is known as a base value, and the second value is the register that holds the displacement value. Or it can also be taken in a vice versa manner. That is, A can hold the register and R can hold the base value. Ultimately, to locate the operand, we need to add the addresses. That is, the address of an operand which is referred to in the register is added with the address of the instruction specified. And then by adding these two addresses, we will be able to locate the operand from memory. So here, rather than directly referring to the address of an operand, we are adding multiple addresses to locate the operand. Hence the name displacement addressing. Relative addressing is similar to displacement addressing, but the only difference here is instead of adding the address to some other source, here we are focusing on adding the address of a program counter with the address of the operand. This will give us the original location of operand from memory. Similarly, we have various other addressing modes like base register addressing mode, index addressing mode, and different combinations like post index and pre index. The final significant one is the stack addressing mode. So in the stack addressing mode, your operand resides onto the top of this stack. So wherever there is an operand that has to be moved onto the stack, and whenever there is an operator that has to be performed by popping out the elements from the stack and applying the operator, once again the result will be pushed back onto the stack. So this stack addressing mode, it requires push and pop operations, and operand performs the operation on top two operands of the stack. Thank you for watching. Please like and subscribe to my videos and share this with all the students who are learning computer architecture and organization. Thank you.